This is the fifth question on the 2002 AP Calculus AB FRQ section. And it reads, a container has the shape of an open right circular cone, as shown in the figure above. The height of the container is 10 centimeters and the diameter of the opening is 10 centimeters. Water in the container is evaporating so that its depth, h, is changing at the constant rate of -3/10 centimeters per hour. Note that the volume of a cone of height h and radius r is given by v equals 1/3 pi r squared h.
Question A reads, find the volume V of water in the container when h equals 5 centimeters. Indicate units of measure. So it's important to note that for this one, you don't actually have to use calculus. You're only finding the volume, and you're given that equation.
For part B, it reads, find the rate of change of the volume of water in the container with respect to time when h equals 5 centimeters. Indicate units of measure. When it says find the rate of change, you look for a relationship between h and r. If there's not a relationship, you just use the product rule to derive, but if there is a relationship, you use this for part B. And just some side notes to remember for this FRQ before we start is always remember your units and then also remember the formulas for volume. Okay, so for part A, they ask you to find the volume of the water in the container when h equals 5. So they give you dH over dt, which is -3/10 centimeters per hour. And they also give you the height of the container, and that's 10 centimeters, as well as the diameter of the opening, which is 10 centimeters. So you know that when the diameter is 10 centimeters, so the radius must be 5 centimeters. In part A, they ask you to find volume when height is 5. So they give you the volume equation, and so it's volume equals 1/3 pi r squared h. So then you can just write it up, 1/3 pi r squared h. And then you know that because it's a right circular cone, that r over h equals 5 over 10, because that's the radius over the total height of 10. Alright, so then because you know this, you can cross multiply, and so you have 5h equals 10r. So then you want to solve for r, so then you just divide by 10, so you have r equals 1/2 h, is what you get. Okay, so then because you don't want to have more than one variable, because there's a relationship between h and r, so you just plug in your variables, so you have 1/3 pi, and then you have r is 1/2 h, so you do 1/2 h squared times h, so you just bring that down. So then you simplify, and you get 1/3 pi, and you square that, so 1/4 h cubed. So then because it only asks you for the volume, you don't have to derive, so then you just plug in 1/3 pi 1/4 times h is 5 cubed, and then you can simplify that. You get 125/12 pi, and then you can't forget your units, centimeters cubed, because it's the volume.
For part B, we want to find the rate of change of the volume of water in the container. So you basically have to derive the equation to find volume. So you're finding dV over dt, so it would be 1/3 pi. So the volume is 1/3 pi r squared h, and you know that r from the previous question is 1/2 h. So you would plug this in before you start deriving, which would simplify to like this.
That's okay.
And then you derive this, so then dV over dt
Want to get me a bun?
equals 1/12 3h squared dH over dt times pi. And so this is just 1/4 pi. H is 5, so it'd be 25 times dH over dt, and then you just simplify this, and you should get -15 over 8 pi, and then units centimeters cubed per hour, because you're finding the rate.